Hello, guys. Welcome to another episode of CUDA Education. Today, I want to go over create um, creating a sampler. Okay, and just briefly to address this topic, this is the first time that I'm actually using or seeing a vkCreateSampler um, function inside of our Vulkan inside of the Vulkan API. And apparently, what happens is that inside of our compute ray tracing example, we have this particular situation here where we're computationally simulating a ray trace scene. So if you have an older GPU, you will be able to run this even if you don't have ray tracing hardware, because we are not taking advantage of the ray tracing functions, and we do not assume that you have ray tracing hardware on your machine. Now, this example you could run, but if you don't have an RTX or greater NVIDIA card or a ray tracing capable GPU, you will not be able to run the ray tracing examples here. Okay. But this idea of a sampler, I haven't seen this before. First time I'm seeing lowercase vk create sampler. And apparently what it is when you create an image, you could basically dictate how you want the image to be read and pushed to the screen. And basically, it is being pushed to the screen via the fragment shader, which is this guy right here, which is this guy right here. Okay, so right now we have the default setting where we're pushing to the screen as whatever the window dictates, but we can also we could also manipulate how it's being pushed to the screen by basically messing around with the coordinates. Now, of course, when I'm dealing with shaders, guys, I have to convert the file. I have to compile the file into SPARV format. So I forgot that step. So we messed around with the in uv.s and uv.t coordinates, and therefore we are able to dictate how things are being pushed to the screen. Okay, so again, the approach is that a sampler, just bear with me, guys, bear with me. um, right, a sampler, the compute shader writes a png file or a jpeg file. The sampler tells how to read the png or jpeg file, and the fragment shader displays it on the screen. um, First time I'm seeing this. So one of the things that we have to understand is that the reason why this approach is used has nothing to do with the fact that this is a compute ray tracing example. Yes, we computationally create an image. Yes, we push that image to the graphics pipeline and basically to the screen. Yes, that is true. But the reason why um, we use a sampler in this example has nothing to do with the fact that we're doing compute ray tracing. The reason we use a sampler in this example is because there's extra processing that you are afforded um, that you are afforded with doing the sampler approach. So those extra things are needed in order to give us the nice display that we see. Let me recompile my shader back to the original. I have to put this back to the original, right? Okay, and then I gotta recompile, and then I gotta run it, right? So just sort of the nice presentation that we have is because of processing that we're doing. Pay attention to the edges. Pay attention to the edges, and you'll see that when we when we mess around with the things that are afforded is linear filtering, smooth scaling, and proper interpolation. So when we mess around with this and we change it from linear to nearest, we're gonna get a slightly different result in terms of our spheres. It's a very subtle thing, but you notice how it's kind of more jagged. It's a more jagged kind of thing. It's the only thing I could notice that's different, right? So this sort of extra processing that is afforded when we have this extra processing that is afforded when we have um, a sampling approach as opposed to just loading an image directly and all that stuff. It creates for a better, it gives us more options. Okay, so we have we have the linear filtering stuff. We also can do, so if we change back, so we're gonna go back and mess around with where stuff is being rendered, right? So we're now back to just doing a portion of the screen, right? But because you do this now, what you can do is you could also now mess around with the scaling, right? So you could do clamp to edge, right? So what's going to happen now is that um, you notice that at the very last set of pixels in the image, we basically repeat it and stretch it. We stretch it all the way to the end of the window, right? Same thing for down here. Notice that we are at the very edge and then we stretch it to the end of the window and we stretch it, right? So there's clamp to edge. There is um, right, there's like clamp to border, which might be something different again. Which I don't know what that is. I don't know. We still see, yeah. So we clamp to border. So I think it's a little bit bigger than what it normally was. All right, so we do go back to clamp to border. Well, anyway, right? So we could mess around with how the image is being manipulated. And then we create, it affords us a lot of options. Now this create sampler portion is inside of, we need to give some context. It is inside of the prepare storage image that is used to store the compute shader ray tracing output, right? So remember, we're computationally creating an image, and then we have our sampler here that gives us the rules on how we actually push it to the screen. Okay, and we have our sampler here that does all of that. That does the final processing. Okay, um, so let me just go through some notes. But it is an important process, and again, the reason why it was done this way is because it gives us an opportunity to do extra processing before it is being pushed to the screen. Now, in another episode, what I want to do is to circumvent the sampler process and just do a straight image load, where we don't have this sort of post processing or thing. And what you're going to see is that when we don't do a texture plus sampler approach, and the reason why I say texture is because notice that it's a texture function here, right? It's a texture function here. So instead of doing the texture plus sampler, we do a straight image load, and what you will notice is that it's supposed to be blocky and pixelated, no filtering, an exact pixel look, right? So there's no massaging of the image to give us that nice presentation. So let me just go through my notes, guys, just so we have better context for our next video, our next episode. Um, so the create sampler code in compute ray tracing.cpp exists so that the graphics pipeline can read sample the image slash sample the image that the compute shader wrote um, right, the ray tracing result. So you have the compute shader, which writes a storage image, which is the ray traced result, which is sampled by the fragment shader, which is this guy right here. And that is outputs to the swap chain image, which is basically outputs to the screen. Okay. Um, so the compute pass does the ray tracing, write pixels. The graphics pass displays the result. That result needs to sample it like a texture. Okay. Um, right. So the sampler object vkSample describes filtering, linear versus nearest, this guy right here, addressing, wrap, clamp, etc., which is this guy right here, right? And level of detail behavior, okay, which is like level of detail. Um, so, right, all of that stuff. The compute shader writes the VK image usage storage bit, but the graphics pipeline reads it as combined image sampler, right? So it's a combined image sampler which requires a VK sampler, which is why we have to have this VK create sampler bit. Let us actually do a control find of sampler. So we see that sampler is used here. It is described in the descriptor stuff. So storage image.sampler, right? It is described in the descriptor stuff. We have descriptor vk descriptor type combined image sampler, which is this guy right here. Again, it is used here in our prepare graphics function. So it is used here. And notice that we have binding 0. Okay, binding 0, which is this guy right here. So we communicate from CPU side application code to GPU side, which is our shader, GPU side code. And we get our sampler color here, which is being referenced in this guy right here, inside of the texture function. So that is how we're stringing things together, right? So we have our sampler, and what have you, okay? Um, Right. So another way to look at it, the compute shader writes a PNG file or a JPEG file. The sampler tells how to read the PNG file, right? Which is all this instruction right here. And then the fragment shader displays it on the screen, which is this guy right here. Okay. Um, Initialize a descriptor for later use. So we have storage image descriptor, image layout, image view, and the sampler, which is our guy right here. Okay. And that's pretty much it. Another way to look at it, the compute shader writes a storage image view plus sampler packaged into a combined image sampler descriptor. The fragment shader samples that image, and then the full screen draw shows result on the screen. Okay. Um, Another thing that we could do is, so for our address mode, so we did clamp to border and stuff. Um, we could also do, so our normal thing is this, right, guys? Our normal thing is this. But we could also mess around with it and do repeat, right? So we could do repeat, which gives us this, right? So we repeat. We could do mirrored repeat, right? Which is this. So we're going left to right, right to left. So it's mirrored, left to right, right to left. Top to bottom, bottom to top, right? So it's mirrored. Um, things like that. Um, and yeah, that's our thing. So again, guys, what I want to do ideally is to circumvent the sampler process and just do a straight image load and see what we get. But that will be in another episode. This is uh, the create sampler process, the image sampling, the texture image sampling. I'll have to figure out how to exactly describe it, but basically we are writing an image and then giving instructions on how to sample that image before it gets to the screen. And again, this is how we do it inside of the texture.fragment shader, which is this guy right here. So let me put everything back to the way it was. Okay, that's back to the way it was. That's back to the way it was. I have to recompile my shader. And guys, you should know by now, every time we make a change to the shader on the fragment, we do a change to a shader, I have to recompile to the spare V format, which is this guy right here. So notice that we're actually reading the spare V file. So I have to recompile this file to spare V so that we could read it. We could read the updates. Okay, so let's run it for a final time to make sure that I'm back to what I was before. I don't want anything, and I think we're on the linear too, right? So we're on the linear. Okay, clamp to border. No funny business with the border, right? It's just one image and it's going to the border. Um, it was clamp to border, right? It wasn't clamp to edge. I don't believe it was clamp to edge. No, I think it was clamp to border. It was clamp to border, but okay. But you guys get the drift. Like, subscribe, share. Tutorial number 1 is installing the Vulkan SDK on your Windows-based machine with a Vulkan-capable GPU. Tutorial number 13 is installing all of these examples on your machine so you could run them and learn the Vulkan API. Thank you guys for watching. Have a great day.